Before Columbus ever sailed west, before European maps sketched the Atlantic's edge with sea monsters and speculation, the Americas were already alive with cities, engineers, astronomers, and architects operating at a level most textbooks barely mention. Across jungles, deserts, river valleys, and mountains, massive urban centers were rising. Pyramids aligned to the sun, road networks cut through impossible terrain, agricultural systems fed tens of thousands. Calendars tracked celestial cycles with astonishing precision. These weren't scattered tribes waiting to be discovered. They were civilizations. Complex, organized, innovative. Some rivaled the largest cities in Europe at the same time. Others engineered landscapes so effectively that modern archaeologists are only now beginning to understand the scale of what was built. And here's the part that makes this even more remarkable. Much of this history was either misunderstood, minimized, or simply ignored for centuries. Today, we're uncovering 10 mind-blowing secrets that reveal just how advanced ancient American societies truly were. Secrets backed by archaeology, scientific research, and hard evidence. This isn't a myth, this isn't exaggeration. This is history most people were never taught. Let's begin. Number 1. The Maya predicted solar eclipses. Set in the period 250 to 900 CE in southern Mexico, Guatemala, Belize. The Maya weren't just building pyramids, they were mapping the sky. During the Classic period, Maya astronomers were recording the movements of the sun, moon, Venus, and other celestial bodies with a level of consistency that still impresses modern researchers. One of the clearest pieces of evidence is the Dresden Codex, a surviving pre-Columbia Maya manuscript that contains detailed eclipse tables spanning dozens of pages. These tables track lunar cycles using what scholars call the eclipse season system. By counting precise intervals between lunar events, particularly the 177 and 148-day cycles associated with eclipse seasons, Maya astronomers could anticipate when solar or lunar eclipses were most likely to occur. Not perfectly down to the minute, but predictively accurate within known windows of time. No telescopes, no glass lenses, no metal instruments, just long-term observation, base 20 mathematics, and generations of recorded data. Built observatories aligned with the stars. Their understanding of celestial cycles was systematic, not mystical. They built observatories aligned with astronomical events, such as structures at Uxmal and Chichen Itza, where light and shadow were intentionally engineered to mark solar movements. This wasn't superstition dressed as science, it was astronomy rooted in empirical observation. When the classic Maya political centers declined between the 8th and 9th centuries CE, the knowledge did not disappear. Archaeological and climate evidence suggests prolonged droughts, environmental stress, warfare, and political fragmentation contributed to the collapse of major southern lowland cities. But the intellectual systems endured. Descendant Maya communities still preserve calendar traditions today. The cities may have fallen, the sky did not, and the Maya were already reading it with precision centuries before Europe developed its own predictive astronomical models. Number 2. Teotihuacan was a multi-ethnic superpower, set in the time period 100 BCE to 650 CE, in the basin of Mexico, central Mexico. Long before the Aztecs rose to power, Teotihuacan dominated central Mexico. By the 2nd to 6th centuries CE, it had grown into one of the largest cities in the world. Most archaeologists estimate its population at between 100,000 and 200,000 people at its height. For comparison, that placed it among the largest urban centers on Earth at the time, comparable to Imperial Rome in scale. But size wasn't its only achievement. What makes Teotihuacan truly extraordinary is its diversity. Excavations have revealed distinct residential compounds linked to migrants from regions such as Oaxaca, the Gulf Coast, and even areas connected to the Maya world. Differences in pottery styles, burial customs, and isotopic analysis of human remains suggest that many residents were not born locally. This wasn't a closed society, it was a magnet, a city powerful enough to attract people from hundreds of miles away. Teotihuacan was also a continental trade hub. Obsidian from nearby volcanic sources was crafted into tools and weapons and distributed widely across Mesoamerica. In return, goods such as cacao, shells, and exotic materials flowed into the city. Its influence is visible in distant regions. Maya inscriptions even record interactions that scholars interpret as political intervention or diplomatic presence. This wasn't isolation. It was urban integration on a scale rarely acknowledged in discussions of ancient American history. The city itself was meticulously planned. The Avenue of the Dead stretched over 2 miles long, anchoring pyramids, plazas, and apartment compounds. These compounds weren't temporary housing. They were multi-family complexes built from stone and plaster, designed for long-term urban life. And then, in the 6th century CE, something changed. Archaeological evidence shows signs of widespread burning in elite compounds. Scholars believe internal unrest, political instability, or factional conflict may have destabilized the ruling structure. Some researchers suggest economic strain or environmental pressures could have contributed. What's clear is this: Teotihuacan did not fall because it was primitive. It fell because it was complex. A multi-ethnic superpower whose influence reshaped Mesoamerica long before European contact, and whose ruins still stand as proof that ancient America built cities at a global scale. Number 3. Cahokia was larger than medieval London. Set in the time period 1050 to 1350 CE, in the near present-day St. Louis, Illinois, USA. In the 11th century, while much of Europe was still clustered in small medieval towns, a massive city was rising along the Mississippi River. Its name was Cahokia. At its peak around 1050 to 1200 CE, scholars estimate the population ranged between 10,000 and 40,000 people, making it the largest known urban center north of Mexico before European contact. For comparison, medieval London during the same period likely had a similar or even smaller population. This wasn't a scattered village. It was a planned urban complex covering roughly 6 square miles, with plazas, residential districts, ceremonial spaces, and over 100 earthen mounds. The largest of these, Monk's Mound, still stands today. It rises about 100 feet high and covers approximately 14 acres at its base, a footprint larger than the base of the Great Pyramid of Giza. And here's the part that makes you pause. It was built entirely from earth. No stone blocks, no metal tools, just soil carried in woven baskets. Basket by basket, layer by layer. Archaeologists believe millions of cubic feet of earth were moved to construct Monk's Mound alone. That level of labor required coordination, leadership, food surplus, and social organization on a massive scale. Cahokia was also part of a far-reaching trade network. Artifacts discovered at the site include marine shells from the Gulf Coast, copper from the Great Lakes region, and stone materials from hundreds of miles away. This wasn't isolation. It was continental connectivity. So what happened? By the 14th century, Cahokia was largely abandoned. Researchers believe a combination of environmental stress, over-harvesting of timber, soil depletion, and repeated flooding from the Mississippi River may have destabilized the city. There is also evidence suggesting social and political shifts that could have contributed to its decline. It didn't vanish overnight. It gradually unraveled. But here's what matters. North America had cities, large ones and organized ones. Urban centers capable of monumental construction and long-distance trade. We just weren't taught about them. Number 4. The Inca built a 25,000-plus mile road network. Set in the time period 1400 to 1533 CE, in the Andes Mountains, western South America. At its height in the 15th century, the Inca Empire controlled territory stretching from modern-day Colombia to Chile. And they held it together with roads. The system, known as Chapac Ñan, extended more than 25,000 miles across some of the most extreme geography on Earth. High-altitude mountain passes over 16,000 feet, arid coastal deserts, dense cloud forests, and steep canyon systems. No wheeled vehicles, no horses, no oxen, just engineering. The Inca carved stairways directly into mountainsides. They constructed stone-paved highways across valleys. They built retaining walls to stabilize slopes and prevent landslides. In areas where cliffs made conventional bridges impossible, they created suspension bridges woven from grass fibers, anchored into stone abutments. Some of these rope bridge traditions continue in the Andes today. The road network wasn't symbolic, it was functional. It allowed rapid communication through a relay system of runners known as chasquis, who could transmit messages across hundreds of miles in days. It allowed armies to mobilize quickly. It allowed goods, food, textiles, and tools to move between ecological zones. Because the Andes don't offer one consistent climate, they offer vertical ecosystems, and the Inca mastered them. Although they did not develop a traditional written script, they created quipu, knotted string devices used to record numerical information. Archaeological and ethno-historical evidence shows quipu were used for census data, taxation records, storage accounting, and possibly narrative information, though scholars continue to debate the full extent of their informational capacity. This was administration without paper, bureaucracy without ink, so how did it end? When the Spanish arrived in 1532 under Francisco Pizarro, the Inca Empire was already destabilized by a civil war between rival claimants to the throne. At the same time, European diseases such as smallpox, which had spread ahead of direct contact, had already devastated populations and weakened political structures. The empire did not fall because it lacked sophistication. It fell because it was hit by biological catastrophe and foreign invasion at the same time. But the roads remain. Stone laid across mountains half a millennium ago still traces the spine of South America, proof that long before European infrastructure projects, the Andes were already connected by one of the most ambitious transportation systems in the pre-industrial world. Number 5. Amazonia was engineered. Set in the time period 500 BCE to 1500 CE in the Amazon Basin, South America. For much of the 20th century, scholars believed the Amazon rainforest was too dense, too nutrient-poor, and too unpredictable to support large, complex societies before European contact. The dominant narrative was simple: small, scattered tribes, minimal infrastructure, no large cities, but new technology changed the story. Over the past decade, LIDAR scanning, a laser-based mapping system that can see through forest canopy, has revealed vast networks of geometric earthworks, causeways, plazas, canals, and settlement clusters hidden beneath the trees. In regions of Brazil and Bolivia, researchers have documented entire urban-like landscapes that were previously invisible from ground level. These weren't random clearings, they were planned. Rectangular enclosures, circular ceremonial spaces, raised road systems connecting communities across miles of terrain. And perhaps even more remarkable is the soil. Much of the Amazon's natural soil is low in nutrients, but archaeologists have identified widespread patches of terra preta, meaning black earth, a rich, dark soil created by ancient inhabitants through the addition of charcoal, organic waste, and controlled burning. Terra preta is not accidental, it is engineered, and it remains fertile centuries later. This suggests that large parts of the Amazon were intentionally modified to support agriculture and dense populations. Some researchers estimate that millions of people may have lived in the basin before European arrival, though exact numbers remain debated among scholars. The rainforest wasn't untouched wilderness, it was shaped, managed, cultivated, then came disease. After 1492, European pathogens such as smallpox spread rapidly through the Americas. In regions like Amazonia, where populations had no prior exposure, mortality rates were devastating. Archaeologists and historians believe that demographic collapse led to widespread abandonment of settlements. Forest reclaimed fields, trees grew over roads, cities vanished beneath the green canopy. What looked like pristine wilderness was, in many places, a regrown landscape, nature covering the remnants of engineered environments. Amazonia was not empty, it was organized, and we are only now beginning to see the full scale of what once existed beneath the trees. Number 6. The Olmec may have invented writing in the Americas. Set in the time period 1200 to 400 BCE, in the Gulf Coast of Mexico, primarily modern-day Veracruz and Tabasco. Long before the Maya carved hieroglyphs into stone, long before the Aztecs built Tenochtitlan, the Olmec were already shaping the foundations of Mesoamerican civilization. Often referred to as the mother culture of Mesoamerica, a term scholars debate but still widely use, the Olmec flourished along the humid Gulf Coast between roughly 1200 and 400 BCE, and one of the most intriguing discoveries tied to them surfaced in 1999. The Cascajal block. This small slab of serpentine stone contains 62 engraved symbols arranged in horizontal sequences. Many researchers believe it may represent one of the earliest writing systems in the Americas, dating to around 900 BCE. However, debate continues. Some scholars argue that without additional examples, it's difficult to definitively classify it as a full writing system. What's clear is this: the Olmec were experimenting with symbolic communication far earlier than once assumed. And their influence didn't stop there. Their artistic motifs, including the feathered serpent and the jaguar, appear in later Maya and Aztec iconography. Their ceremonial centers, such as San Lorenzo and La Venta, featured massive platform mounds and carefully planned layouts that set architectural precedents across the region. Then there are the colossal stone heads. 17 have been discovered so far, each carved from basalt boulders transported from the Tuxtla Mountains, some weighing up to 20 tons. These stones were moved across distances of up to 60 miles, likely using manpower, rollers, and river transport. No draft animals, no metal tools, just logistics, coordination, and engineering knowledge. The heads themselves depict individualized facial features, which many scholars believe represent rulers or elite figures. So what happened to the Olmec? They did not disappear overnight. Around 400 BCE, major Olmec centers declined, likely due to environmental changes, shifting river systems, or political transformation. But their culture did not evolve. Their religious symbols, artistic styles, and urban planning concepts were absorbed and transformed by later civilizations. The Olmec didn't collapse into obscurity, they became the foundation. And if the Cascajal block truly represents early writing, then the story of literacy in the Americas may begin centuries earlier than once believed. Number 7. The Maya built cities without rivers. Set in the time period 250 to 900 CE in Yucatan Peninsula, southern Mexico, Guatemala, Belize. Most ancient civilizations grew beside rivers. The Nile, the Tigris and Euphrates, the Yellow River. But many major Maya cities, including Tikal, Calakmul, and Caracol, were built in regions with no major rivers at all. So how did they survive? Water engineering. The limestone bedrock of the Yucatan Peninsula absorbs rainfall quickly, meaning surface water disappears fast. The Maya adapted by constructing massive reservoir systems, some capable of holding millions of liters of water. At Tikal, archaeologists have identified interconnected reservoirs lined with plaster to prevent leakage. They also carved chultans, underground cisterns cut directly into limestone, designed to collect and store rainwater from rooftops and plazas. This wasn't temporary improvisation, it was urban-scale hydrology, underground. Some cities engineered drainage systems to prevent contamination, separating drinking water from runoff. Recent studies of sediment cores from Maya reservoirs even suggest the use of filtration systems involving sand and mineral deposits. Engineering kept them alive, but climate tested the limits. Paleoclimate research, including lake sediment analysis and cave stalagmite data, indicates that between the 8th and 10th centuries CE, the region experienced prolonged and repeated megadroughts. Scientists believe these drought cycles strained agricultural output, reduced stored water, and destabilized political systems dependent on reliable surplus. The reservoirs worked, until the rain didn't. The classic Maya collapse was not caused by ignorance or lack of sophistication. It was a stress test of even the most advanced water management system in pre-Columbian North America. They built cities without rivers, and for centuries they made it work. Number 8. Tenochtitlan was built on a lake. Set in the time period 1325 to 1521 CE in Lake Texcoco Basin, present-day Mexico City. In 1325, according to Mexica tradition, a group of migrants saw an eagle perched on a cactus, rising from the waters of Lake Texcoco. and they built a city there, not beside the lake. On it, Tenochtitlan, the capital of the Aztec Empire, was constructed on an island in the middle of a shallow, brackish lake in the Valley of Mexico. What sounds impossible became one of the most impressive urban experiments in pre-modern history. The key was innovation. The Mexica engineered chinampas, artificial agricultural islands, created by layering mud, vegetation, and lake sediment between woven reed fences. These raised fields were extremely fertile and allowed multiple harvests per year. Scholars believe chinampa agriculture produced yields high enough to support a dense urban population. This wasn't symbolic farming, it was large-scale food security. To connect the island city to the mainland, they built massive causeways, raised roadways that functioned as both transportation routes and defensive barriers. Sections could be removed during invasion, turning the lake into a natural moat. The city itself was laced with canals. Spanish conquistador Hernán Cortés described it as a city of waterways, bridges, marketplaces, and whitewashed temples rising above the lake surface. Some early European accounts compared it to Venice, though in scale and organization, Tenochtitlan rivaled or exceeded many European capitals of the time. By the early 16th century, most historians estimate the population exceeded 200,000 people, making it one of the largest cities in the world in 1519. Then came collapse. In 1521, after months of siege by Spanish forces and indigenous allies, compounded by a devastating smallpox epidemic that had spread ahead of direct conflict, the city fell. Warfare destroyed infrastructure. Disease decimated leadership and civilians alike. Tenochtitlan was dismantled, but it was not erased. The Spanish built Mexico City directly atop its ruins. Today, beneath the streets, beneath the cathedral, beneath the foundations of one of the largest cities in the Western Hemisphere, lie the remains of temples, canals, and chinampas. The lake is mostly drained. The empire is gone. But the foundation of modern Mexico City still rests on a civilization bold enough to build a capital on water and make it thrive. Number 9. Poverty Point. Predates the pyramids of Giza, set in the time period 1700 to 1100 BCE in the northeastern Louisiana, USA. More than 1,000 years before the rise of Teotihuacan, and centuries before the Great Pyramid of Giza was completed, a massive earthwork complex was rising in what is now Louisiana. It's called Poverty Point. At first glance, it doesn't look like a pyramid city. There are no towering stone temples, no carved monuments. Instead, there are enormous concentric earthen ridges, 6 massive curved embankments forming semicircular arcs that stretch nearly 3/4 of a mile across. At the center stands a large platform mound rising about 70 feet high. And here's what makes it extraordinary. It was built by hunter-gatherers, not large agricultural states, not empires supported by intensive farming. For a long time, archaeologists assumed monumental construction required settled farming populations producing food surplus. Poverty Point challenges that model. The people who built it relied primarily on fishing, hunting, and foraging. Yet they organized labor on a massive scale. The construction required moving millions of cubic feet of earth, by hand, basket by basket. Excavations have also uncovered trade materials from remarkable distances: copper from the Great Lakes region, stone from the Appalachian Mountains, and marine shells from the Gulf Coast. That means long-distance exchange networks spanning hundreds of miles existed here over 3,000 years ago. Poverty Point eventually declined around 1100 BCE. The exact cause remains uncertain. Scholars suggest environmental changes, shifting river systems, or changes in trade patterns may have played a role. But the bigger takeaway is this: complex society doesn't always follow the same formula. You don't always need intensive agriculture to build monumental landscapes. You don't need stone pyramids to demonstrate social organization. Sometimes complexity rises from mobility, trade, and cooperation, and leaves behind earth instead of stone. And for centuries, it sat in Louisiana soil, quietly rewriting what we thought we knew about early North American societies. Number 10. The Nazca Dru, pictures you can only see from the sky. set in the time period 200 BCE to 600 CE in the Nazca Desert, southern Peru. In one of the driest places on Earth, an ancient culture carved its presence into the desert itself. The Nazca lines are enormous geoglyphs etched across nearly 200 square miles of arid plateau. Some stretch over 1,000 feet long, depicting hummingbirds, monkeys, spiders, whales, geometric spirals, and long straight lines that run for miles. And here's the part that still feels unreal. You can't fully see them from the ground. The Nazca created these images by removing the dark, iron oxide-coated stones on the desert surface, revealing the lighter-colored soil beneath. The contrast forms clean, visible lines that have remained intact for nearly 2,000 years. No heavy machinery, no aerial view, just planning, measurement, and coordinated labor. How did they map them so precisely? Researchers believe the Nazca likely used wooden stakes and simple surveying techniques to scale up smaller drawings into massive designs. In fact, archaeologists have found wooden stakes embedded in some of the lines, radiocarbon dated to the Nazca period. As for their purpose, debate continues. Some scientists believe the lines had ritual significance, possibly linked to water ceremonies in a region where rainfall is extremely scarce. Others suggest astronomical alignments may have been involved, though large-scale astronomical interpretations remain controversial among researchers. What is widely accepted is that the Nazca culture placed strong spiritual emphasis on landscape and water, and these geoglyphs were likely part of ceremonial pathways. So why are they still visible? Geography. The Nazca Desert is one of the driest regions in the world. It experiences minimal rainfall, little wind erosion, and stable ground conditions. Without vegetation or significant weathering, the lines remained preserved for nearly 2 millennia. Sometimes preservation isn't mystery, it's climate. The Nazca didn't build upward like the Maya or Aztecs. They built outward, across the Earth itself. And from the sky, their message still stretches across the desert floor, silent, enormous, and still not fully understood. Ancient American civilizations weren't isolated. They weren't primitive. They were astronomers, engineers, urban planners, agricultural innovators, and environmental managers. Their decline wasn't caused by ignorance. It was climate stress, warfare, political change, and later disease and colonization. History didn't begin in 1492. It was already thousands of years deep. And we're only just beginning to understand how much was there.